Ever wondered how computers in a network know where to send the data packets? The answer lies in subnetting. Subnetting, a fundamental concept in networking, is a process that divides a network into two or more networks. It's like the postal system of the digital world, directing data packets to their correct destinations. This crucial mechanism ensures efficient data transmission, minimizing congestion and enhancing security. Intrigued? Stay tuned to understand the step-by-step process of subnetting. Before diving into subnetting, grasp the basics of IP addresses and network classes. Now, what exactly are these IP addresses? They're essentially the unique identifiers that devices use to connect and communicate within a network. Think of it as the postal address for your device in the vast world of the Internet. There are two types of IP addresses, IPv4 and IPv6. IPv4, the older version, uses a 32-bit number system, which means it can support up to 4 billion unique addresses. Meanwhile, IPv6, with its 128-bit number system, can support a staggering number of unique addresses, enough for every atom on the planet, and then some. Now, these IP addresses are divided into 5 classes, A through E. Each class has a different range and is used for different purposes. Class A is designed for large networks with millions of devices. These IP addresses start with a number between 1 and 126. Class B, on the other hand, is for medium-sized networks. These IP addresses start with a number between 128 and 191. Then we have Class C, which is meant for smaller networks. These addresses begin with a number between 192 and 223. Classes D and E, however, are a bit different. Class D is used for multicasting, where data is sent to multiple recipients at once. Class E, meanwhile, is reserved for future or experimental use. You might wonder, why do we need to know all these details about network classes? Well, understanding these classes is key to subnetting, as it helps in planning the organization and segmentation of a network. In essence, subnetting allows for better management of IP addresses within a network, leading to improved network performance and security. And there you have it, a brief overview of IP addresses and network classes. By understanding these fundamental concepts, we're laying the groundwork for our discussion on subnetting. With the basics in place, we're ready to delve into subnetting. Scene script. Subnetting begins with identifying the network and host portions of an IP address. Imagine an IP address as a street address. Picture the network portion as the city you live in and the host portion as your specific house within that city. For computers to communicate effectively, they need to identify not only the network, but also the specific host within that network. Now, how do we distinguish the network portion from the host portion in an IP address? That's where subnet masks come into play. A subnet mask is like a sieve that separates the network portion from the host portion. It's a 32-bit number that masks an IP address and divides the IP address into network and host addresses. The subnet mask is made up of 2 parts. The left side contains the network portion, represented by 1s, and the right side contains the host portion, represented by 0s. When a subnet mask is applied to an IP address, the network portion is uncovered by aligning the 1s in the subnet mask with the corresponding bits in the IP address. Let's take an example. If we have an IP address of 192.168.1.1 and a subnet mask of 255.255.255.0, then the network address is 192.168.1 and the host is 0.1. This is because the subnet mask 255.255.255.0 tells us that the first 3 octets, or the first 24 bits, belong to the network portion. The remaining bits, which are zeros in the subnet mask, belong to the host portion. Subnet masks play a vital role in network communication. They help routers determine whether the destination of a packet is within the same network or a different network. If it's the same network, the packet is delivered directly. If it's a different network, the packet is sent to the router's default gateway, which then routes the packet to its destination. Now that we've identified the network and host portions, it's time to create subnets. Creating subnets is like partitioning a large office space into smaller cubicles. Now imagine each cubicle represents a subnet, a smaller section of a larger network. In the networking world, we create these subnets by borrowing bits from the host portion of an IP address, much like how we'd partition an office space into cubicles. Think of an IP address as a large open-plan office. The network portion is the entire office building, and the host portion is the open space within the building. By borrowing bits from the host portion, we're effectively creating partitions or walls to form smaller individual cubicles or subnets. So, how does this help in network management? Well, creating subnets allows us to break down a large, unwieldy network into manageable, bite-sized chunks. This makes it easier to monitor and manage network traffic, and it also helps to isolate issues when they arise, as they're confined to individual subnets rather than affecting the entire network. On top of that, subnets can significantly reduce network congestion. Much like how cubicles can prevent a single loud conversation from disturbing the entire office, subnets limit broadcast traffic to within the subnet itself. This means that a high-traffic event in one subnet won't slow down the entire network, just like how a noisy meeting in one cubicle won't disturb the entire office. In essence, creating subnets is all about improving efficiency and control. It's about making a large network more manageable and less prone to congestion and widespread issues. It's about ensuring that the network can run smoothly and efficiently even as it grows and evolves. So, we've created our cubicles, our subnets, but how do we tell them apart? How do we know which cubicle or subnet is which? That's where subnet addresses come in. Just as each cubicle has a number or a name, each subnet has an address that allows us to identify it and manage it effectively. Subnets are created, but how do we identify them? That's where subnet addresses come in. Subnet addresses help us identify the various subnets in a network. Subnets or subnetworks are smaller networks within a larger network, and their addresses are like a map guiding data packets to their destination. Let's break down how we calculate a subnet address. We start with the network portion of an IP address, which identifies the network to which the IP address belongs. This is like the street name in a postal address, but we don't stop there. We also need to consider the borrowed bits. These are bits that we take from the host portion of the IP address to create subnets. Think of these as the house numbers on our street. They help us pinpoint exactly where to deliver our data. So, how does this work in practice? Let's imagine we have an IP address of 192.0.2.0 and a subnet mask of 255.255.255.0. The network portion is 192.0.2 and the borrowed bits are represented by the 0 in the subnet mask. When we combine these, we get a subnet address of 192.0.2.0. Simple, right? The beauty of this system is that each subnet address is unique. This is crucial for successful data transmission. If two subnets had the same address, it would be like two houses with the same number on the same street. The mailman wouldn't know where to deliver the mail. In the same way, if two subnets have the same address, our data packets would get lost. Having unique subnet addresses also allows for efficient routing. Routers use these addresses to decide the best path for data transmission. The more subnets we have, the more paths are available, which can increase the speed and reliability of our network. So, to sum it up, subnet addresses are more than just numbers. They're the roadmap that guides our data packets to their destination. They're the house numbers on our network street, and they're the key to efficient and successful data transmission. With subnet addresses, our computers now know where to send the data packets. Subnetting might seem complex, but it's a powerful tool in network management. As we wrap up our discussion, let's recap the key points we've covered about this crucial aspect of networking. First off, we delved into the understanding of IP addresses and network classes. We learned that each IP address is a unique identifier for a device on a network and is composed of network and host portions. Network classes, on the other hand, help define the size of the network and the number of hosts it can accommodate. Next, we identified the network and host portions of an IP address. The network portion tells us which network the IP address belongs to, while the host portion identifies the specific device within that network. Then, we ventured into the realm of creating subnets. By dividing a network into smaller subnets, we can improve network performance, enhance security, and make better use of our IP address space. Finally, we learned how to calculate subnet addresses. This involves the use of binary conversions and bitwise operations, but don't worry, with practice it becomes second nature. Let's not forget that subnetting is much more than a theoretical exercise. It's a practical tool that can enhance the efficiency of data transmission within a network, making it a vital skill for any network engineer. Remember, subnetting is all about efficient data transmission in a network.